We have three vertices or corners of a triangle. We're told D is the midpoint of side AB, and we're asked to show that CD is perpendicular to AB. So first of all, we need to actually work out what D is. So D is the midpoint of AB. So if we use the midpoint formula, we're simply going to work out the average of the x coordinates for AB. So 0 plus minus 2 divided by 2, and the average of the y coordinates, which is 2 and 8 divided by 2. So that gives us minus 1 and 5 for the coordinates of D. So to show that they're perpendicular, we need to show that their product of their gradients is equal to minus 1. So the gradient of CD is going to be equal to y2 minus y1 over x2 minus x1. So that's going to be, if looking at CD, it's going to be 5 take away 12 over minus 1 minus 20. So that's minus 7 over minus 21, which is 1/3. The other gradient that we need is the gradient of AB. So that's going to be 8 take away 2 over minus 2 minus 0. So that's 6 over minus 2, which is minus 3. So as a third times minus 3 equals minus 1, CD and AB are perpendicular. The next part says find the exact value of tan CAB. So what we have worked out is that we have a triangle first of all, and we also know that AB and CD are perpendicular, so we can draw the triangle from this. So we want the exact value of tan CAB, so C to A to B is this angle just here, so the tan of CAB is equal to the opposite over the adjacent, so that's CD over AD. So the distance CD, well, that's going to be equal to the square root of x2 minus x1 all squared, so that's going to be minus 1 minus 20 squared and 5 minus 12 squared. So if we look at that on our calculators, that comes out to be 7 root 10. And AD, similar thing, that's going to be 0 minus 1 squared and 2 minus 5 squared, which is equal to the square root of 10. So the tan CAB is equal to CD, which was 7 root 10, over root 10, which is 7. And the final part, C, squeeze this in just here. Name the geometrical name of the triangle. Well, if the perpendicular here splits these two lines in two, then it means that these two sides are the same length, so we've got an isosceles triangle.